Perfect. Welcome back to the shed. Now, if you follow my channel, you'll be very familiar with the old Wig-Wag engine. Of course, I built this about, it's going back a few years now, 5, maybe 6 years, I can't remember. And it is a beautiful little engine, nice and easy to build. You know, if you're new to model engineering, this is a very, very good place to start, really. But since then, of course, it's evolved somewhat, and one of the other engines I built was let's have a look, was the Wig-Wag V-Twin, which again, a beautiful engine, really worked out nicely. And well, it carried on. There's about 10, 11 maybe different engines in the series. And then I built the duplex engine, and that obviously requires a second chassis. Now this one gave me a little bit of trouble because some of my machining wasn't obviously 100% absolutely perfect, and you know, when you tightened up the bolts it'd lock up because there was obviously a discrepancy between the bearings for the main crank. And then another one I built, again this is just a 3 version of the single Wig-Wag design, and they're linked together through crank pins in the centre there. And again, this one gave me a bit of trouble as well, you know, getting that alignment right. I mean, it's fine now, you know, if you work at it, it'll work out good. But the reason I'm telling you that is because, oops, wrong one. Done it again. Wrong one again. Right, the Wig-Wag V-Twin, I always wanted to like maybe double it up, V4, or 3 of them, V6, or maybe a V8. Or maybe even, I don't know, you can carry on for miles, can't it? But the thing that sort of held me back, one, was, well, this chassis, it was quite an awkward cutout to be able to, you know, it involved quite a bit of machining and stuff like that. And of course, due to the shape of it, it's quite wasteful of material as well. So if I was going to build like a V6 or something like that, you know, I'm just going to use up an awful lot of metal. So I looked into getting some sort of quotes for either laser cutting or water jet cutting or CNC machining, whatever the you know, was available. And well, I was a bit disappointed because it was very expensive. So I wanted to build a V8, so that means I need 4 of these. And like I say, you know, I got quotes from different companies around the UK. Well, that was it really. It kind of, the price put me off, so I thought, well, it's never going to happen really, is it? But then out of the blue, randomly, seemed to be perfect timing. It's one of those things that you think, somebody's helping me out here. But anyway, I was contacted by a company called JLC PCB, I think, or something like that. I'll put the correct name of it, you know, in the video somewhere down here. And there'll also be a link into the to the company that helped me out. Now, I was quoted, it was something like between £400 and £600 to have 8 of these made. Is that right? No, it's not 8, is it? It's 6 of these made, sorry. And a friend of mine, or a friend from the Wig-Wag Facebook group, he drew up some STL files for me, which I'd used, like, you know, previously to send off to get the quotes, etc. And well, this company came back to me, and it was an absolutely superb price. Basically, just £100 for 6 of these, plus 20 quid shipping. So yeah, I went for it, and well, you know, I was thinking, well, they might be okay, they might be a bit rough, whatever. I mean, the important thing for me is that they all line up, because that's the most difficult part from building previous wig-wags. To get that line of the axle shaft, so it doesn't kind of bind or anything like that, is actually really quite difficult. So anyway, when they did turn up, I mean, they didn't take long, actually, about 4 or 5 weeks, something like that. And there was obviously the 6 of them. They had some, funny machining marks. I mean, it's as flat as anything, so I guess it's just the thingy. But when you give it a scrub with a wire brush, etc., and it comes up, well, absolutely gorgeous, really. So that's the raw one. That's as it came, and as you can see, there's no sharp edges or anything like that, and the holes themselves are fluctuated a little bit from the original drawing, simply because I didn't want to put a 12mm hole in there and then find it was a bit loose or something like that with the bearing. So I specified 10 and 5. But you know what? They were absolutely bang on. They were actually so bang on that a 10mm, ground dowel pin wouldn't actually go in, because there was no clearance whatsoever. Absolutely bang on. So I've had to run the reamer through them, and yeah, they're absolutely brilliant. Absolutely love them. This was my well, I'll tell you what, I'll show you the engine, shall I? Gosh, I can't believe I've been keeping this one from you so long. Cue the music. So there you go. Okay, so this is the V8 engine, which I've built, and as you can see, it uses 4 chassis, so 4 of these. The reason I ordered extra was because this was my guinea pig, so all the machining operations I did on this one first. I've had to set it up. Because what I've had to do, one thing that I've had to do, because there's so many components and they all need to be identical, so each, 8 of everything all needs to be identical. So I've done loads of well, I've made little jigs and fixtures and stuff. That was a jig for the crank in the lathe. I don't know where I've put the other bits, to be fair, but I do have some video footage of it, so it's probably there now. So yeah, that was my guinea pig, and that was my spare, just in case. Okay, you can't be too careful, but actually they're both completely good, therefore I could just keep going, but maybe not just yet. So right, well, without further ado, I'll actually get it, get a bit of air, compressed air on it. That should be long enough, I think. What I'll do first of all, actually, because I'll stick a bit of oil in just to lubricate the cylinders. I'll say about 2 inches, that's normally about enough. And then, well, the actual air connection is round here and under there. And I mean, it was quite a puzzle really of how I was going to supply this this engine with air, because I mean, if you remember on the triple, that was simply fed. I mean, it was good fun making that actual supply manifold, I suppose. But you know, it worked fine straight into the sides, nice and easy, if a little tricky to make. As this one, you know, I didn't have the sort of option of the air intake just being on the one side, because the air intake needs to be on that side on this one, and it needs to be on that side on that one. So it's slightly unbalanced, if you know what I mean. I mean, I wasn't happy with that. So basically what I did, and I'll show you on this actually, I drilled a hole which was going to accept the 3/16 brake pipe, this sort of stuff. That's the one there. And then what I did is I drilled down to sort of go through and all the way down to the air, you know, the inlet port for the cylinder. And then the idea was that when the engine was kind of all assembled and sort of turning over, you know, nice and free by hand, I'd be able to insert some sort of, you know, copper brake pipe. And then what I did, if I can sort of make sense of it for you, once it was all together, I inserted some copper brake pipe. I mean, obviously I had to make the crossover pipe there, which was just simply done out, you know, nice and easily really. Give it a good bit of annealing, and then it pops into some quarter tube as well, and it's just, well, it's kind of a little bit of Loctite on there, a little bit of blue Loctite just to seal it from the air, but obviously it can be removed if necessary, but hopefully it never will. And yeah, so I've sort of put the pipe through, you know, all the way through, well, holding the pipe to make sure it doesn't move while you're doing the machining, and then drill through halfway into the pipe, so just off the one side. And then of course you end up with something like this, which has got the hole in. Obviously there was 4 holes, and then you can you know, when you reassembling the engine, then you put it all back together, and you simply rotate around, so that now creates the hole down the port into the port into the cylinder. And then of course you can it's tapped there for M4, I think it was, so that then you can just pop a grub screw in there just to secure it as well. Yeah, so there's the little grub screw just in there. Now the exhaust, like I say, it was difficult to decide. I mean, it took a bit of thinking about, because obviously the exhaust on the let's call it the left hand side is at the top, and the exhaust on the right hand side is at the bottom. So you know, I couldn't have an exhaust pipe there and have an exhaust pipe there again for the same reason, for the inputs. You know, it would just look unbalanced and non-sophisticated. So what I did, again, this is going to be a long video, I think, sorry about that. I drilled down, I haven't done it on this one actually, but I basically drilled a hole down to meet the exhaust port, you know, to join up with it. I actually come off at the side a little bit because I wanted to use the 1/4 inch pipe. So I come off the side a little bit and came down, so it basically just intersected about halfway through the exhaust port there. And well, there you go. And when I actually put them together, I mean, the main reason for me wanting to have have them machined, one, I didn't fancy machining it myself, because I just knew that my level of accuracy is never going to be that good. I mean, these are obviously just sat on here at the minute rather than on a a flat plate. But yeah, I mean, I've bought some 5mm dowels, sorry, not dowels, silver steel rod, just so I could put those in position. And I bought some 10mm, well, I didn't buy that, I already had it, but got some 10mm rod as well. And I couldn't not believe it, when I tightened up the bolts on the bottom of that plate, everything still just turned. It was absolutely quite amazing, really. I was quite shocked. So again, that shows the level of quality that I got from JLC, whatever it is. Put it on the screen again, sorry. But yeah, I mean, so if you're thinking of building something which is, I don't know, maybe a little bit sort of a challenge, then do start looking for other ways to do it. I mean, that company does all sorts of things. I mean, it's called JLC CNC or something like that, but they do printed circuit boards, to your design, but I think basically anything you want. If you ask them to do it, they'll do it. And well, yep. Anyway, that's the Chinese economy is obviously flourishing. Right, we're going to get it on some air now. I'll just turn the compressor off so it doesn't sort of kick in halfway through. Okay, so the airline comes in there, and obviously there's a cutout in the copper pipe in there, which allows the air to flow in and also allows the air to run, all the way around, supplying all the cylinders as it goes. They're just blanked off here at the back, simply because of maybe in the future it could carry on, couldn't it? Well, we'll see about that. So, get a bit of air on. It should be self-starting. It runs clockwise from the flywheel, I think. Or have I got that the other way around? No, I'm wrong. It runs clockwise from that angle. So let's give it a whirl. Just check that's in shot on the close-up camera. I just need to come in a bit. Don't like that strobing. Anyway, so there you go. And well, I think you'll agree it's quite a beast of an engine. These little exhaust pipes that I put in, they've got like a quarter inch, well, little like solder elbows that I found again in the land of China. And I just thought they were nice, all sort of pointing, in one single direction, a bit like the the exhaust manifold you'd perhaps find on a high-powered Mopar, American vehicle or something like that from the 1970s and stuff. Yeah, and I kind of like them. I think I went a bit too far, a bit too high on a couple of them. But, I tried to keep them basically the same height, so a slightly shorter one there, because obviously the exhaust comes out the top, and a slightly longer one down there. But yeah, let me spin it round. I mean, it runs absolutely lovely. Let's just check that balance. I'll give it a spin up. Just check it's in focus. Yeah, okay. I'll give it a spin up. And it will, of course, run, well, pretty quick. Now I don't know what RPM that is, but it's basically tanking along, so as you can see there. But you know, the whole sort of the whole idea about model engineering is that you can get your engines to run as slow as possible. So we can dial it right down to probably, I don't know, 4 or 5 psi. I'm not sure what, because I haven't got the a regulator that sort of gives me that data. It's still a bit of black oil coming through there, look. Just give that a bit of a wipe away. Just keep it nice and clean, because obviously, you know, we all know that these engines get quite dirty. I mean, most of it is running pretty sweet, actually. I mean, I was if you stop the engine and find a point where it will stop. No, maybe not. Okay. Anyway, so what the way I've got it set up at the minute is in what they call cross plane. So the first cylinder, you know, if say that the crank of that is fully at the top dead center, yeah, the next one is then 90 degrees to the right, or you know, so where's it going that way? 90 degrees behind, yeah. And then again, the next one is 90 degrees behind that one, so 180 degrees from there, and then the last one obviously again completes the cycle. Now as the cylinders, I mean, if you imagine when they, I mean, let's start with that one. So that's about to get air, yeah, so it just comes over the hill, boom, it's got air. But this one also now has just got air as well, so it's kind of like you know, it gets a pulse and then a pulse, rather than you know, because I mean, you know, a real V8 of course is well, it's a 4-stroke. Obviously this is a 2-stroke, so but you've got plenty of power, and then obviously you've got the power behind that, and the power behind that one, and the power behind that one, and then it starts all over again. And so yeah, it's got a fair bit of power. Obviously I haven't tested the torque. It's still running in, because it's still tighter than you know, I'd usually like. So it does need to spend a few more hours. As you can see, I like them to be able to, you know, pull over. Whoops. Pull over on their own like that. As this one still requires a little bit of, you know, it doesn't spin, but it will get there. We will get there. So I'll drop a bit of oil into these little oiler cups on the top. These lubricate the what do you call them, the bearings. Now the bearings of course are you know, these are phosphor bronze that come through from the other side, and they've got like a turn down section that will, you know, be force fitted into the chassis, and then the length is set so that the next crank, you know, can be attached to that. And you've obviously got a what do you call it, the pin, the journal pin, I think it's called, through there, which connects the actual crankshafts together. One end is obviously not attached, well, you know, it's not fitted, it's not solid, so it'll come through. And of course I can set the I've actually bought some smaller grub screws. These were all I had at the time. I think they're about 7 8 mil long, so I have bought some shorter grub screws, which I will replace. But like I say, at the minute it's running in cross plane, so it'd be nice to sort of be nice to try it in a flat plane configuration. So I'm just going to get a bit of footage of it running cross plane, and then I'm going to make some adjustments. Cross plane. Okay, so now what I'm going to do, you probably won't really be able to see what I'm doing here, but as you can see there, the little the grub screw. It's quite tight. But then of course it's free, you know, that's free to move because it's not now attached. So cross plane, we're going to go one way there and one way there. So it's just kind of, well, we'll roughly squeeze that up. So they're basically opposite each other. I mean, it doesn't matter if they're not quite right because each engine will run independently anyway. So then this one, I need to turn it around so I can get to the grub screw. How we doing there? So I'll just slacken that off, and then of course I want to go, where's that one's there, so this one now wants to sort of match the one over there, doesn't it? So okay, I'm a little bit misaligned, but I mean it's just a test. So and that I suppose is the nice thing about this, you know, the sort of axle configuration is, you know, you can modify it. I mean, we could have them all running in synchronized if I wanted to. I mean, that might be something I might try another time. Let me just get that round there. I think actually that one, I think I've squeezed it up a bit too much and it's pulling a bit tight, so I just need to push that back. Yeah, that's better. Let's just nip it up. And then the last one, I guess. There you go. Keep it over there. And what I'm looking for on this one, up, down, up. So this one wants to be down. So if I bring that one round to down, bring that one down, and then this one can come up. That's it. Tighten it up. Yeah, it'll be interesting to see how it runs. Okay, so off we go. We're going to give it a good run. Hopefully it'll sound slightly different anyway, if nothing else. Yes, it self-starts. Yeah, you can definitely hear that, definitely hear the difference there. Let's get a bit more air on. Maybe not when it's running fast, but I think when you get the slow tick over, it's got that. Okay, so I've done a couple of runs with it in cross plane and flat plane, and I've recorded it, and well, I can't hear a lot of difference, but so it's over to you. So, what do you think sounds better? Is it cross plane or possibly flat plane? Or aeroplane? Bloody buggers. Always spoil my recording. It's over to you. What do you think? Almost. It's almost got the pulse of a V8. But I believe the you know, your typical American car, which has got a lovely sort of you know, that engine noise that you get from you know, a big block Chevy or something like that. It's that is actually in cross plane, I believe. Don't quote me on that. And that kind of, apparently that's what gives it that nice sort of rumble. But anyway, there you go. What more do I need to say about this? Well, not a lot really. I mean, it was it's all been like I say, it's all been machined precisely so that everything is matching. You know, all the crank discs are the same. You know, the pins are the same, everything's the same. 4 little oilers there, and of course you can you know, you can bring a bit of oil, introduce a bit of oil through the supply pipe as well. But yeah, there you go. Still a bit oily, like I say, but it's you know, I can't sort of, no, I can't stop it. And I think that's quite nice, actually. I've got to get a little, oh, it's quite a heavy little beast. I've got to get a little brass plaque made for that recess that I've cut out there. By the way, the actual main base is just attached via 2 screws to the wooden base, and obviously these have got 2 screws each, and I've also doweled them as well. I've put some little 4mm dowels into there, just so that, well, basically I had to take it apart probably 16 billion times, and no, I'm not exaggerating. Well, I might be a little bit, but yeah, because I had to keep taking it apart, getting it realigned every time, it was a nightmare. So I got it perfectly aligned, you know, by using that 10mm shaft, 10mm shaft and the 5mm shafts. Pinched up all the screws, made sure everything still ran nice and easy, and then I turned it over and drilled the other side, reamed it, and popped some dowels in. So now, you know, if I want to take it apart, I can, and I know it'll go back straight into the correct positions. Well, that's about it from me. Hope you enjoyed my latest projects. I apologise for being like 6 months down the line since I last did anything that you can enjoy from me. Well, I'm still working. I'm not retired yet. I'd love to be retired because I've got 1,000,001 projects, 200 million projects actually, and I'm not exaggerating. Anyway, thank you for joining me. Hope you're all good at home. One little thing I did want to say: there's a guy on YouTube, Rusty Inventions. I mean, he's a lovely guy. He's doing great, actually. I love his videos, love his machining and that. But he paid me a really nice compliment. I'd sent him a sticker over, and he sort of did a sticker update on the other stickers he'd had, and I think he called me the Wig-Wag King, or the King of Wig-Wags, or whatever it was. And I just loved that. I thought that was great that he had appreciated what I'd done. So but yeah,
he does make nice engines, steam engines. He is, in my opinion, the king of the Wig-Wag or Wobbler engines. The Wig-Wag or Wobbler engines, in my opinion, is a good engine to start with.
So I'll do a few like sort of close-ups and that kind of arty-farty video-y stuff that people do, and then that'll be the end of the video then. So I just want to say thanks for watching, and if you've not subscribed to my channel, please subscribe, give it a like, give it a thumbs up, and well, that's it then. Enjoy the rest of the summer, and I'll see you soon with my next engine, which is it's a nice big petrol engine. Actually, it's a single cylinder 4-stroke. You might have seen it in my last video, but now it's finished and it's absolutely beautiful. So I'll be back with that. Okay, so see you all. Thanks for watching. Bye.